Hey everybody, welcome to Unit 8.4. Today we're going to start with Part 1, talking about the discriminant, which is part of the quadratic formula, and how we can use that to gain information about our quadratic function. Okay, so our quadratic formula, the entire thing, x equals, and this gets us the roots. Okay, we saw that in solve by graphing and solve by factoring. When we get our roots, we leave the expression as x equals and then the value. Okay, the rest of our formula is red. The opposite of b, plus or minus, because we're going to end up having two options, square root b squared minus 4ac, and then that entire thing, including that opposite of b and the plus or minus, is all divided by 2a. So the values of a, b, and c that you see there in the formula come from ax squared plus bx plus c. Those are the coefficients from our quadratic formula. Okay, so today we're going to be looking at just the discriminant. It's the expression inside the radical of the quadratic formula. So it's just that portion in red there, b squared minus 4ac. We do not, I repeat, do not include the radical when we are calculating the discriminant. Now, what does the discriminant do for us? Okay, I want to preface by saying it does not solve the quadratic function. It does not get us the roots, but it gives us information about the roots. Okay, the discriminant is used to calculate how many roots. So we saw from solve by graphing, we could have one root, we could have two roots, we could have no real roots, and the nature or what kind of number they are. So again, we saw from solve by graphing, we have two real rational roots, we have two irrational roots. Those were the estimated ones. We could have one rational root, or we could have no real roots that we're now going to call two imaginary. Okay, it does not give the specific x value where it crosses the x-axis. It does not give the root the discriminant. It just tells us the number and nature of the roots. So how many and what kind of number? Is it a whole number? Is it an irrational number, meaning it's a repeating decimal? Okay, so there are four possible outcomes that we're going to need to memorize. So when your discriminant evaluates to be a perfect square, so 4, 9, 16, 25, those are perfect squares. That means that if we were to solve that quadratic formula and find the roots, we would get two real rational roots. So that means it crosses the x-axis at two different whole numbers. Okay? If our discriminant is a non-perfect square, so any other number in the world, okay, then that means we're going to have two real irrational roots. So irrational is just those ugly, non-whole numbers. It could be like a repeating decimal. It could be taking the square root of something that's not a perfect square, so like the square root of 5. Okay, that's irrational because that comes out to be a repeating, non-ending decimal. Okay, so this two real irrational, this is equivalent to two estimated roots when we did solve by graphing. Our third option is 0. Our b squared minus 4ac evaluates to be 0. Well, then that means we're going to have one real rational root. So that means that the vertex of the parabola is the one point where it crosses the x-axis, and it's going to be a whole number. That's what rational means. Okay, and last but not least, if we get a negative number as our discriminant, that means that the parabola is not going to cross the x-axis. So when we solved by graphing, we said there were no real roots. Now we're just going to say that it's too imaginary. Those two statements are equivalent. So no real roots and too imaginary are equivalent. Okay, we say too imaginary though, because you're going to see in the next part of 8.4 that imaginary is a more descriptive word as to what's actually going on in the situation. Okay, so any negative number. All right, so let's put this into action. So we're given here a quadratic function. You want to make sure that all of the terms are on the same side. That means set it equal to 0. And then we're going to identify our a, b, and c. A is 9, b is negative 12, and c is 4. So we're going to now plug it in to our discriminant. Sorry, got away from me there. Okay, so plug this in to b squared minus 4ac. Okay, use parentheses. Okay, and then we're just going to plug that into our calculator exactly as it appears so that we don't mess up any signs. Okay, we evaluate this correctly. We get 0. Okay, so what does that tell us? The discriminant equals 0. So that means there's going to be one real rational root. Okay, so if we were to take this function and solve by graphing or solve by factoring, or in the next lesson we're going to solve by quadratic formula, this graph would hit the x-axis at just 1 point. Now this is not necessarily what that graph looks like. I'm just showing you an example. But this is the situation that the graph would look like. We understand solve by graphing. We've already done that. Okay, so it's nice to know before we solve the equation what kind of answer we should get, because we can use the discriminant as a way to check our answer. Okay, we'll do one more of these. So here's my function again. Make sure that everything is on the same side and it's set equal to 0. We're going to identify our a, b, and c. Okay, and then we'll plug them in and evaluate to analyze our discriminant. So again, using parentheses, okay, and we plug that in exactly as it appears using the parentheses, okay, making sure that it's minus 4ac, okay, and we find that this equals negative 8. So that means our discriminant, the value there is negative 8. Well, that's a negative number. Okay, the fact that it's a negative comes before the fact that it's a non-perfect square. Okay, so we're classifying this as a negative, which means that this is going to be two imaginary roots. Okay, and remember from graphing, this means that it does not cross the x-axis. So our parabola could perhaps look like this. Okay, and that would give us no real roots, or now our more formal description of it is two imaginary roots. Okay, I'm going to stop there. This is part 1 of quadratic formula, just identifying the discriminant and analyzing the roots.